Let's solve a popular problem from binary tree, and this problem is, you can see from the LeetCode, and it's saying like count good nodes in a binary tree. So this is the binary tree, and we need to find out good nodes, and then these nodes highlighted in blue, they are good nodes, and we need to find that count. So we need to understand what is the criteria for the good node. So we can start from root, and any number that's first number, that's a good node. But if you go to the right side, we have to see that that value is equal to or greater than this 3. So 4 is greater than 3, so this is also good node. And 5 is greater than 4, that's also good node. 1 is not greater than 4, so it's not a good node. So we can start from here, and we can say, okay, 3 is our max value, and 3 is equal to our max value, so 3 is a good node. And when we go to right side, we can check the 4 is greater than 3, so 4 is good node. So but 4 is also greater than this 3, so in the right side portion, now 4 is max so far. So that is the 4 is max. Now we need to check the 5 is greater than equal to 4 or not. So yes, so that's also good node. So that's the definition, and exactly we are going to do the same logic. We'll traverse left and right, and we maintain max so far in the left side and right side, and based on that, just check that each node value is greater than max so far, and if it is greater, then we can increment the count. So that's the logic. This question has been asked in many companies, so you can see here, that's the list. Amazon, Meta, Microsoft, Google. Yeah, so let's write the code. So since I can easily traverse this in a left right, but we need to maintain also max so far, because from here 3 is a max, but if you go to the right side, the 4 will be max, so I need to have one helper function. So let me copy paste this, and I will name it helper, and here one more variable I'll just pass here, max so far int, and I can call this function root, and max so far we can start from the root, so root dot val is max so far. We'll come and we can check here root equal to nil. If there is nothing, then good node is 0, so that's condition we check here, and I can say that's a good node. That's a good node is 0, and I want to return this good node count. So that's all, and then I just call this function root dot left, traverse left side, and max so far, and whatever the good node if I get from the left side, I can increment that in a count, that is good count. So that should be plus, just increment this. We traverse the same thing in the right side. That's all, and we can have the core logic here. You can check here if this root dot val greater than equal to max so far, then count that is good plus plus, and we can, when we go to the left side or right side, we need to maintain the max count, so we have to check which is the max. So we can check with the root value and the max so far, and whoever is max, we can store that in a max so far. We need a function for the max. Let me write that function. If a greater than b, return a or return b, and I can have the function here max so far equal to max function, and then I can pass max so far, and also this root dot val. Let's run that, check for syntax. Undefined max so max so far. Accepted, submit. So that's all. Let's check the code once again, and you can see the Java solution also. It's exactly same logic. Variable is a little bit different, but logic is exactly same. So that's all for today. Thank you.